Hi, I'm David Terezo Sanchez, and this is a presentation of Cloud Deployment Manager, the first and only tool to automagically deploy whole clouds from a diagram with just a click of a button. Really. In its current version, Cloud Deployment Manager concentrates years of deployment experience in a very simple user interface, so easy to use that even a beginner without any training could deploy tens of roles without sacrificing neither power nor control. Cloud Deployment Manager represents the cutting edge of DevOps research and innovation on the Windows platform and Microsoft's data center products. Cloud Deployment Manager is a departure so radical from the past it brings the future to the present. Cloud Deployment Manager highlights the right path to systems architecture. Not only it provides the tool every system architect have always dreamed of, it's just how things should have always been. Because in the long run, the how things are done transform the world of the why. Cloud Deployment Manager makes a quantum leap on how systems are currently architected. It's born to be the perfect tool for the systems architect to enhance how systems are currently deployed and how they are documented by enabling, for the first time, the declarative documentation of the system infrastructure of a full data center. Cloud Deployment Manager is more than a technical feat. It's about product innovation driving process innovation. Thanks to Cloud Deployment Manager, infrastructure deployment metamorphosed from fixed bedrocks to sandcastles. Now you're able to build dozens of installations, benchmark, and destroy them without worries. And start again until satisfied. And the finally generated documentation is declarative and replicable, enabling a new whole kind of knowledge base. Remember, things are just not done. They are done with elegance and style. Cloud Deployment Manager is so versatile it can be run on your PC thanks to the integration of Hyper-V on Windows 8. In this demo, Cloud Deployment Manager will be used to deploy Operation Manager and Orchestrator in different virtual machines, each featuring their own installation of SQL Server on a new Active Directory forest in another virtual machine. For this demo to work, you just need enough hard drive space, more or less 75 GB, and enough free RAM memory for the virtual machines to start, a minimum of 4 GB. Since this is just a demo, an operation manager will not be monitoring hundreds of machines, the memory requirements are quite low. But remember that real production deployment should only be created after careful assessment and capacity planning processes, following all the recommendations and best practices. To speed up the deployment process, I use a solid-state drive, since Cloud Deployment Manager is IOPS intensive, the main bottleneck of deployment processes being the copying of files. You are in the Preview tab after starting Cloud Deployment Manager. In this tab, you can browse through past saved deployments to look for all the deployments that may be of any utility to your current needs. For the sake of the example, let's suppose that no previous deployment fits our needs. Ratio, we click New, and after introducing a new file name, a new entity diagram appears. Notice how in the left part of the screen there are shapes classified by product category: Configuration Manager, Operations Manager, Orchestrator, General shapes, each including different shapes representing the role of every product. Of particular interest is the category of General shapes. Within this category, there are Microsoft SQL servers, version 2012 and 2012 R2, instances of Microsoft SQL Server versions 2012 and 2012 R2, a guest virtual machine, a dynamic connector between shapes, and a pre-configured virtual machines to host a new Active Directory forest. In the topmost part of the application's reviewing the ribbon, we see that it contains multiple operations. File operations like save, undo, and redo. Clipboard operations to cap, copy, and paste. Zoom operations to zoom in, zoom out, pan and zoom, fit to window, and the rest. Connector operations to connect the raw shapes with the SQL's instances. Arrange operations to group and ungroup shapes, which is used to associate the rows of every System Setup product to its corresponding virtual machine. Operations to read to from and send to back the shapes and group, and operations to check the data of shapes, which is a way to store the settings of every row and virtual machine. There are also two buttons at the bottom of the application. The Verify button checks that the created diagram has been properly configured, that the required set of information has been correctly entered. After it has been clicked, another message appears. The Deploy button can be pressed, and then the real magic begins. The diagram will start to be deployed, and information, warning, and error messages will appear in the Trace tab. Within the diagram, there are three pages: the current black one, which will contain the diagram, and two more pages, one with general installer variables like product keys, the user, and organization, and another page with implicit settings that will apply to all the deployed machines, if not explicitly replaced with other settings in the individual configuration of a virtual machine. We plan to deploy two virtual machines with one processor each one. These are the dynamic memory settings, the domain configuration, the paths where the files of the virtual machine will reside, the network adapted settings, the basic SQL configuration that will be applied to every SQL server, and the disk and drive settings. Back to diagram page, the first decision to be taken in every deployment is whether an Active Directory forest will be needed. If not, the Active Directory used will be the one configured within the machine from which Cloud Deployment Manager is being executed on. Note that this will require permission enough to create users, groups, organization, and units settings. In other words, the normal set of permissions that every System Center deployment requires. For this demo, we want a new Active Directory forest separate from the one this machine is joining in. So we drag the AD domain controller from the General Shapes category and draw it to our blank diagram. In the right-hand side at the shapes data, we can set various parameters, like the name of the virtual machine, DC locale01, domain name, by default contoso.com, the number of processors, 1, and startup minimum and maximum memory, 10, 24, 768, and 1536, and many more settings, like the number of data disks or where a DVD should be present. Let's suppose that these default settings are the right ones for our deployment. That's all we need to specify the deployment of an Active Directory forest. It's really this easy. Never mind the creation of virtual machines and the promotion of Active Directory. From now on, deploy with class with Cloud Deployment Manager. Then we drag our first virtual machine and draw it to the diagram window. As in the previous case with the virtual machine containing the Active Directory, we can change a lot of settings. The amount of RAM memory is the most important setting to change. Note that the virtualization host on which this guest virtual machine will be installed on is also set here. Depending Cloud Deployment Manager, we use the local Hyper-V server. Next, we start dragging and dropping roles of Operation Manager. The Operation Manager management server, with lots of settings like the name of the management group or all its service accounts. The Operations Manager console and Web console. And finally, the Operation Manager Data Warehouse server that we will start in the same server, since this is just a demo scenario. See how easy it is to build a deployment of Operations Manager with Cloud Deployment Manager, and remember how difficult it is by using the traditional procedure, especially in previous versions. Forget all about complex commands, group policies, and registry settings. Now deploy with style with Cloud Deployment Manager. We also need a SQL server and SQL instance on this server for this Operations Manager to work, whose shapes are in the Common Shapes category. If this were a production environment, the SQL server and its instance will be stored in another server, but for demonstration purposes we will use the same virtual machine used by Operations Manager. There is an extra step that needs to be carried out for each SQL instance. Even if every SQL instance is implicitly related to a SQL server but virtual of its grouping, the roles of every system center product need to be explicitly related to the corresponding SQL instance. Toward that end, a connector is created to join the shapes of every SQL instance and the syntax center role. This is an operation that is best carried out by clicking on the main role shapes, the management server, then on the SQL instance, and lastly on the Connect Shapes button at the top of the screen. Done. Now see how we have put behind the Error Pro installation of SQL Server in the tab of clusters of SQL servers, which is also supported. We just gracefully deploy with Cloud Deployment Manager. Then we align all the roles on top of the virtual machine. Next, we select all the shapes, exclude the connector from the selection, and click on the group operation. These are the steps we must use to tell the Cloud Deployment Manager that it must deploy all the roles, SQL Server and SQL Instance on the selected virtual machine. And that's all. Operation Manager is ready to be deployed. For the sake of completeness, we will include an orchestrator role on this deployment. Watch how it's exactly the same procedure for the other roles and products. Once you have created one, you've learned everything you need to know. To continue, we drag our second virtual machine and drop it to the diagram window. Note that this virtual machine will require much less memory than Operations Manager, since this product is much less resource intensive. Now drag and drop the roles of the orchestrator product. The orchestrator management server, on whose settings we find a default service account, admin group, and installation directory, settings we will shall conserve for this deployment. The orchestrator runbook role, and finally the orchestrator web components role. We also need another SQL server and SQL instance on this server so this orchestrator will work. We drag and drop them and use the previously explained operation to create the corresponding association between the role and the SQL instance. We select the main role shapes, the management server, then the SQL instance, and lastly we click on the Connect Shapes button at the top of the screen. Next, we align all the rows on top of the virtual machine. Select all the shapes, exclude the connector from the selection and click on the group operation. And that's all. Orchestrator is configured and our desired deployment is ready to be deployed. There are only two steps left to deploy our servers. First, we need to click on Verify. This feature inspects all the pages, settings, virtual machines, and rules, looking for errors before any deployment is started. If no error message is displayed after clicking on it, it means that we are ready to deploy. The magic happens now. With the click of a button, the deployment will start. A new window opens from which all the deployment commands are being executed. Everything from the creation of guest virtual machines and their storage provisioning to the install of Windows features and rules, rebooting to install patches and hotfixes, the installation of system setup products and their configuration, including any interaction between them. After 1 hour, the deployment has finished. If we open the local Hyper-V Manager, we can see that all the machines are correctly deployed. And when we open console to the guest virtual machines, we are able to check that the products have been correctly deployed. As a tool, Cloud Deployment Manager is the best exponent of what could be achieved in the Windows platform within the field of DevOps, that is, the integration of the processes of development and operations. But DevOps is much more than cheaply managing thousands of servers. The automation of the data center or the continuous deployment of fixes and new features. Long-term speaking, DevOps in conjunction with cloud computing will significantly alter the technological landscape and the economic relationship between the actors of the computer industry. History is a guide, and the Jevons paradox is the best starting point to understand what's to follow. The Jevons paradox asserts that technological progress that increases the efficiency with which a resource is used tends to increase, rather than decrease, the rate of consumption of that resource. This paradox was coined after pondering on how technological improvements in the 19th century that increased the efficiency of the use of coal led to increased consumption of coal in a wide range of industries, contrary to common intuition. Fast forward to today, cloud computing is triggering the same effect. The number of big virtual machines, virtual networks, and storage is only growing at an accelerated pace, and that includes the underlying raw material and inputs needed to manufacture them. And DevOps, with tools like Cloud Deployment Manager, is just the innovation on processes allowing all this to happen, the lubricant that keeps the engine at top speed. Paradoxically, the outcome of all these advances is very difficult to get measured in the economic statistics. You can see the computer age everywhere but in the productivity statistics. And when they get measured at all, it's after a very long time. In other words, there is a very long time lag in the recognition of the benefits of computer technology, because they mainly manifest as spillovers to other industries. The benefits of cloud computing and DevOps must be accounted in units different than the customary virtual machines provisioned per minute, or even the more encompassing saved costs due to their use. The units and key performance indicators that should be used are those of the target industries on which they are applied. In the next slides, I will review what will be the expected effects of Cloud Deployment Manager on the diffusion of System Center. And for a better understanding of the full effects of cloud computing, I will digress to the more general topic of the impact of computer technologies like Cloud Deployment Manager to the general economy, just for the sake of knowledge. First, we should start with the specific case in our hands, that of improving the diffusion of System Center. With the release of System Center 2012, the real game changer was the bundling of all the products under a new license. In theory, economics predicts higher profits from the mixed bundling of products rather from the separate selling, under the conditions that the consumer value for the products are negatively dependent, independent of with just a limitedly positive dependence. This is especially true with business software, in which buying follows almost rational patterns, unlike consumer software. For our purposes, the most realistic case of this theory was the Office Suite wars of the 90s, in which Microsoft Office prevailed, crushing the competition with the integration of a word processor and a spreadsheet and a suite, among other programs. In other words, bundles are very good anti-barriers against single-product competitors, but not against another bundle. That is the conclusion of a research paper by Gander, Markovich, and Riordan, where it is shown that counterfactually, if Lotus and WordPerfect had emerged, Microsoft Office would have not reached market dominance. Fast forward to today, the same history applies to the System Center suite. Just as in the past, various demands for every product of the System Center suite are negatively correlated, and the suites of the competition offer less products and features. But unlike the yesterday's software wars, the current bundle is not market effective, since every product of the System Center suite is deployed but separate, and their integration is far from being easy. That is, even if the products are jointly licensed, they don't feature an installation as easy as the one offered by the Microsoft Office, rendering the licensing effectively useless as a tool for market expansion. Microsoft risks market dominance due to these technical barriers to deployment. Moreover, take into account that these products are used by technical specialists that may have a very scarce knowledge of any other product that is not of their interest. Such is the power of the default option. If by default all products are jointly deployed, so shall they stay together, and IT administrators will learn to use the adjacent products by reason of their association with those of their current knowledge. Fortunately, Cloud Deployment Manager comes to save us from this state of affairs. It drops the barrier so low that even lay users may deploy the whole System Center suite with all the products fully integrated. It's possible to predict how Cloud Deployment Manager will impact the diffusion of System Center and the future state of data center software. As a technical innovation, it's a skill-biased, capital-intensive, positive technology shock, with a strong productivity enhancer. It also makes workers perfectly sustainable at the most entry level, but only in the tasks related to basic installation. Past technologies show that the kind of shocks created by products like Cloud Deployment Manager drive up output as measured by gross revenue, per capita hours worked, consumption, and investment. In this slide, the figures show the result from econometric models of previous technology shocks akin to the present one. More specifically, as Cloud Deployment Manager saved hundreds of hours of error-prone configuration tasks, it depends on the capital level substitution effect. thus easing investment. In the medium run, will lower prices, increase productivity, but the weight premium of seasoned experts in relation to that of beginners should stay the same. Since also some entry-level tasks are removed, it will only release lower resources from the more cumbersome installation processes. At the end, Cloud Deployment Manager will increase the installed base and market opportunities of those knowledgeable of the System Center suites. Traditional market forces will adjust the supply-demand relationship, like it always happens with any other typical technological change. The supply curve will shift to the right and to the bottom, increasing supply and lowering prices. Quantity supplied will be greater than it was prior to the shift for each and every price level. Long run, changes that increase productivity due to technological progress always shift the long run aggregate supply curve from S sub 1 to S sub 2, increasing general output from Y sub n to Y sub n prime. In the figure at the left, the skill premium is represented in the vertical axis, and the horizontal axis represents the relative employment rate. The rendered curves represents the case in which the technology is skill biased and endogenous, so the relative lower demand curve is outward sloping. The movement from point A to point B identifies the effect created by technologies that raises the skill ratio, like Cloud Deployment Manager, ultimately generating an upward shift of the labor demand curve that also generates an increase in the relative employment rate of the skill and the skill ratio of the employed. In the figure at the right, the capital skill substitutability relation is shown in response to an investment shock. The bottom line represents the empirical skill premium and is one standard deviation from the mean as reddish lines. The dashed line shows the responses of a model of the skill premium, ranging from very weak complementarity to very strong substitutability. In the event of investment-specific shocks, econometric model shows that capital and skill are very strong substitutes rather than complements. Therefore, the skill premium decreases and the relative price of investment goods increases in response to skill-biased technology shocks. Thus, the dashed line that most closely matches the empirical skill premium in the figure is the one with very strong degree of capital skill substitutability. In fact, the estimated parameters imply that the capital skill stock increases by 1%, firms can still produce the same amount of output as before with 1.7% less of their low-skilled workers or a match of up to 5% of the high-skilled workers. Of interest to the study of the effects of technological change on employment is also how wages are going to be impacted. In the computer industry, workers are not perfectly substitutable, and there are heavy fixed costs. Think about all the hardware and the software in the data centers. The figure in this slide represent how the wages of the skilled workers go down initially as the group starts to adopt a new technology, especially the wages of the skilled workers who do not adopt the technology themselves yet, facing larger relative losses than when their more productive colleagues adopt the technology and increase the level of output of skilled labor in efficiency units. Overall, this has negative impact on the price of the skilled output. Later on, when unskilled workers adopt computer technology, the trend reverses. And finally, when the diffusion is complete, the between-group wage inequality moves back to its initial value. And when the technology cost converges to zero, the relative difference between all workers disappears. After reviewing these facts about technological change, we turn back to our main topic. What about deploying a Cloud9? And what's a Cloud9? a whole System Center cloud. Use the Cloud Deployment Manager to deploy a Cloud9 in just 3 hours with a click of a button. It doesn't get any easier. Currently, all System Center products are supported, including those coming in the next version of Windows Server R2 and System Center R2. Configuration Manager provides secure and scalable software deployment, compliant settings management, and comprehensive asset management of servers, desktop, laptops, and mobile devices. Operations Manager monitor and manage your infrastructure and applications to identify and respond to operational problems. Virtual Machine Manager, Microsoft management solution for the virtualized data center. It lets you configure and manage your virtualization hosts, networking, and storage resources to create and deploy virtual machines and services to private clouds. App Controller, from a single console, manage applications across the private cloud and the Windows Azure platform. With App Controller, you can manage services instead of computers by putting application components in the context of the service that it represents to the business. Service Manager provides built-in processes for incident and problem resolution, change control, and asset lifecycle management. Service Manager offers an integrated platform for automating and adapting your organization's IT service management best practices, such as those found in Microsoft Operation Framework and Information Technology Infrastructure Library. Orchestrator, automated creation, monitoring, and deployment of resources in your environment using this workflow management solution for the data center. Service Provider enables service providers and hosts to design and implement multi-tenant self-service portals that integrate infrastructure as a service capabilities available on System Center 2012 R2. Data Protection Manager protect and recover data from Microsoft workloads like Exchange, SQL Server, Hyper-V, SharePoint, file servers, and clean computers. Windows Azure Pack runs Windows Azure inside your data center, offering rich, self-service, multi-tenant services that are consistent with Windows Azure. When used in combination with Service Management and Automation, also offering Cloud Deployment Manager, you will be able to automate common administrative tasks in the management portal. Cloud Deployment Manager is also ready for the next version of Windows Server and System Center R2 due out next week. Its improvements enable the creation of real hybrid clouds between on-premises deployments and Azure, and System Center is yet the beginning for Cloud Deployment Manager. Every server product from Microsoft will be eventually supported. I live hoping you have enjoyed this presentation. Get a fun and happy deployment with Cloud Deployment Manager.